I'm Krishna Rao Patro. Today we are discussing about the definition and terminology of the first module of your data structure concepts. So in the previous session, you've seen the varieties of concepts on related to data structure. So now we'll see what are the different terminologies are there and how they are asking in the exam. Those things now we'll discuss. Generally, frequently they are asking even in the interview or even in the exam, internal exam, external exam, everywhere they are asking. So the basic things you should know. So it requires a little bit rehearsal. The first question they'll ask, what do you mean by data structure? Then you should say data structure is a way of organizing the data so that it can be used efficiently. So whenever you want to answer, you should answer in this way. A data structure is a way of organizing the data so that it can be used efficiently. So here we have used the two words for efficiency purpose. One is time and another one is space. Because whenever you are using the concept of data structure, you have to give more importance to time and space. So whenever a program is written, the program should consume less time to execute, as well as the program should consume less space to solve the problem. These are the two main factors you should keep in the mind. So as a best software developer, you must keep the time and space is the minimum. If the program takes more time, then that is not at all a efficient program, or you are not at all a efficient program. Similarly, you have to take less time and space factor. Okay, this is the general definition of data structure. Then they will ask the hierarchy of the data structures. We can broadly divide the data structure into two types. One is linear data structure. Second one is non-linear data structure. Okay. Under linear data structure, the various items are like, one is array, second one is stack, and next is queue, and next one is linked list. These are all comes under linear data structure. Linear data structure means what? Linear means whenever the data is organized in a sequential manner, that time that data structure is known as linear. But there are some information where you have to organize in a non-linear pattern. So that means in a hierarchical pattern. Those are called non-linear data structure. So under non-linear data structure, you will have a graph as well as you will have a tree. So the graph and tree will be organizing in a hierarchical pattern. So that's why they comes under non-linear data structure. So most of the time in exam, they'll ask what is linear data structure or what is non-linear data structure. Then you should say linear data structure organize the data in a sequential manner. Whereas in a non-linear data structure, the data will be organized in a hierarchical order. Okay. Now, your array comes under linear pattern. Stacks comes under linear pattern. Queue comes under linear pattern. Linked list also comes under linear pattern. That's why they are all linear data structure. Of course, there is one more simple variable. A simple variable also a linear data structure. Sometimes in exam they may ask a question, which is the simplest and smallest linear data structure? Then you should say variable. Every variable which can store only single data, that also comes under linear data structure. Then what is the array? Array means which will be storing the data in a sequential order in a contiguous manner. Then what do you mean by stack? Stack also a list which follows a order called last in first out, LIFO list. Stack follows last in first out order and it is represented in a vertical manner. So whichever comes last, that will be removed first, last in first out. Similarly, there is another linear data structure that is called queue. Queue which follows the order called FIFO, first in first out, FIFO. So whichever comes first, that will service first. So stacks, queues also comes under linear data structure. Similarly, in the case of linked list, which is also arranging the data in a sequential manner, but here the difference is what? It will be organizing data in a runtime manner or in a dynamic manner. So how much memory required for storing the data is not known in well advance. So whenever such scenario comes, then use always linked list. Whenever the number of data are well known before processing, then go for always array. Array will be useful for storing data in a fixed manner. That means you cannot change. The memory allocation will be done before compilation. This is static. Array are static, whereas linked list is dynamic. So you must be remembering which is static and which is dynamic. Similarly, graph comes under nonlinear. It will be organizing data in a nonlinear pattern, but in a graph you will find set of nodes and set of edges, and there may be some cycle also. There may be some cyclic pattern also. But in the case of tree, you will find set of nodes and set of edges also, but you will not find any cycle. So it is a non-cyclic graph. So whenever the informations are arranged in a hierarchical manner, then those are comes under nonlinear data structure. Fine. Now they may ask a question: what is linear data structure? Then you should say a linear data structure is a one type of organization where the data elements are arranged in a sequential manner. Please remember the word sequential manner. And each member of element is connected to its previous as well as next element. That means there is a link between next and previous element. And examples of linear structure, that is list, queue, stack, array, these are all linear data structures. Similarly, your linked list also even. And remember, under linked list also, maybe a single linked list, double linked list, circular single linked list, circular double linked list. These are all comes under linear data structure. Even though the name is circular, but still the data will be arranged in a sequential manner. Only logically that will be circle. So that's why they are comes under also linear data structure. So all types of linked list comes under linear data structure. Similarly, they may ask a question: what do you mean by non-linear data structure? Then you should say the data structure where the data items are not organized in a sequential manner. That means in a hierarchical order. So not organized in a sequential. So you can say it is a hierarchical order. So when the hierarchical order comes, those are comes under non-linear data structure. So you must be very careful. Whenever data is in a hierarchical order, those organization is known as non-linear data structure. They may ask a question: what are the examples of non-linear data structure? The examples are like trees and graphs comes under non-linear data structure. A tree is a collection of nodes where these nodes are arranged in a hierarchical and form a parent-child relationship. So that comes under non-linear data structure. And remember, under tree also there are various types of trees. Some are binary tree, some are strictly binary tree, and some are general tree, and some are binary search tree, some are AVL tree. So all kinds of trees comes under non-linear data structure. So remember, your binary tree, your general tree, your binary search tree, as well as your strictly binary tree, complete binary tree, your full binary tree, as well as your AVL tree, as well as your red black tree. Whatever the kinds are there, all types of tree comes under non-linear data structure. So you must be very careful. Sometime in exam they may ask a question whether AVL tree is a linear or non-linear data structure. Then your answer is non-linear. Or sometimes they may ask the set of item they will give, and you have to find out which one is not a non-linear data structure. They may give the options like this. Find out which is not a non-linear data structure. Not a non-linear data structure. They may ask a question like this. They may give the first option, stack, next tree, next graph, next AVL tree, Which one is not a non-linear data structure? Tree is linear. Sorry, non-linear. Graph is non-linear. ABL tree is non-linear. Only the stack is linear. That's why the answer is A. So this way you can answer. Okay. Next. They may ask a question. What do you mean by algorithm? And why do you need the algorithm? Then you should say algorithm is a finite sequence of instructions and each of has a clear meaning and can be performed with a finite amount of effort in a finite length of time. So this is a general definition. An algorithm is a finite sequence of instructions and each instruction has a clear meaning and can be performed in a finite amount of effort and in a finite length of time. Then such set of sequence instruction is called algorithm. Or in a simple form, you can say algorithm is a set of instructions which perform a specific task. An algorithm must satisfy the following criteria. Sometimes in exam they may ask a question, what are the main criteria for a algorithm to satisfy? Then you should say there are 5 criteria. What are the 5 criteria? One is input, because input is the main one for the algorithm, because based on the input it has to process. Without input you cannot do anything. So it must have either 0 or more quantities are externally supplied. Sometimes even 0 also. That means there are static input. You need not give and you need not enter the data also. In that case, 0 input will be given by the user. Similarly, output. Whenever you are processing the data, then that means after taking the input, you may give some output. Those output you have to display. So output is also main requirement, because after processing the program, you have to get the output. So the output must match with your requirement. If output is not matching, then that means algorithm is not written properly, the meaning. So while writing algorithm, you should keep in mind, one is input, second is output. After giving input, you have to get the corresponding output. If output is not coming, then you should say this invalid program or the algorithm is wrong. So you have to keep output in mind. The third one is definiteness. That means each instruction must be clear and ambiguous. So while solving the problem, you are writing set of instructions. That instruction must be very clear. There must not be any ambiguity. If there is ambiguity, you cannot solve the problem. That's why it must be clear and it must not have any ambiguity. Then fourth one is finiteness. Finiteness means what? If you trace out the instructions of an algorithm, then for all cases, the algorithm must terminate in a finite number of steps. That means whatever the instructions you are writing, it must be stopped after finite amount of time. It must not take infinite time. It must not go for infinite steps. It must be solved in a finite steps. So every algorithm must have instructions which must be terminate in a finite amount of time. It must take fixed time. It must not go for infinite. Sometimes some program may go for infinite. So the system may hang up. So we must check whether it takes means finite time or infinite time. If it is infinite time, that means something is wrong in the algorithm. Next one is effectiveness. Every instruction must be very basic so that it can be carried out. Whatever the instructions you are writing or whatever the steps you are writing, it must have some effect to the algorithm. Simply just like that, if you write, then unnecessarily you are increasing the time as well as space. So there must be some effectiveness of the instructions. Because while writing algorithm, the algorithm may have set of instructions. Those instructions must have some effect. If there is no effect, then no use of writing. So keep in the mind for the 5 factors: input, output, definiteness, finiteness, and effectiveness. They are the 5 criteria while writing the algorithm. Because everybody will write the algorithm, but while writing algorithm, simply if you write just like that, then that is invalid algorithm, which may not be feasible, solution for the problem. Next, there is one more important concept called what is recursion. See, when you want to solve a problem, you can solve the problem either by a non-recursive way or recursive way. Recursion means what? Which can be solved by calling the program itself. When a process, the process in which the function calls itself directly or indirectly, that is called recursion. When the process is calling itself, then that is a recursive process. That means when a function is calling itself, that is a recursive function. The recursive function is alternate for your loop. Generally, you can solve a problem using loop. Now, if you want to remove the loop that you want to write in an alternate way, then you can choose the recursion. So, recursion is an alternate for loop. So, when the program or a function which is calling itself, that is called recursive function. The process of calling is called recursive. The function is called recursion function or recursive function. Then they will ask a question, what are the base criteria for recursion? Then you should say, the criteria for the recursion is actually condition to be satisfied. If condition is not satisfied, then it may go for infinite. That's why whenever you are writing a recursion, you must have one base criteria to terminate. If recursion is not terminating, then it will go for infinite. So unnecessarily, it will be occupying memory because internally, whenever it is calling, it will be keep on occupying memory. That's why there must be a proper base criteria. That means the condition must be written properly when it is to terminate. Second one is what are the parameters you have to pass also. One is base criteria for condition, and second one is the parameter. What parameter you have to pass? Parameter for function. If parameters are not passed properly, then it may also give wrong result. That's why the base criteria or base condition as well as parameters. These are the two important things you have to remember while writing the recursion. Second, there are two types of recursion actually. One is finite recursion, second is infinite recursion. Finite recursion means what? It may stop after certain amount of time. That means it will be satisfying some base criteria. If base criteria is not satisfying, it will keep on calling. So, in that case, that is called infinite recursion. So, if a recursion never reaches the base case, that means base case is not written properly, then in that case, it will go for infinite recursion. Next, they will ask, if there is no base case criteria in a recursive program, then what will happen? They will give the multiple choice question also sometime. First option is not executed. Second is execute infinitely. Third one is execute until all conditions match. And fourth one is obtain a progressive approach. They may give the four conditions. Condition is what? If no base criteria satisfied. If there is no proper base criteria. If base criteria is not written, of course, it will go for always infinite. That means it is executing infinitely. So, answer is 3. Then they may ask another question. What is the data structure used for recursion? Then answer is stack. Remember, stack is a data structure which is used by recursion. And stack follows which order? They will ask stack follows which order? Stack follows LIFO order. Because most of the time in exam they will ask which order is followed by stack. Then you should say LIFO. Last in, first out. Then they will ask what is tail recursion. Actually, there are two types of recursion. One is head recursion. Second one is tail recursion. Or regular recursion and tail recursion. Generally, in the case of head recursion or general recursion, the function will be calling at the beginning itself. In the code segment, you may write multiple statements. So, in the code segment, if you write the recursive function in the beginning itself and the remaining statement is below, then that is head recursion. Whereas, when you write the function at the end of the code segment, then that is called tail recursion. So, they will ask a question, what do you mean by tail recursion? If a recursive function calling itself and the recursive call is the last statement, so remember the word last statement. If the statement, that means the function is at the end of the function, then it is called tail recursion. Because while writing a recursive program, there may be multiple statements. If the last statement is the function itself. That means the function is calling itself. Then that recursion function is called tail recursion. If at all it is somewhere in the middle, then that is not a tail recursion. Because in the tail recursion, you will not have anything to do when it is returns. Everything is done before calling. So after the call recursive function, it performs nothing. The function has to process or perform any operation at the time of calling, and it does nothing at returning time. Underline this word. So when it is returning, it performs nothing. Okay. So this is the way you can answer. Yeah. Now they'll ask a question. This type of question they may ask: what is the output of the following code? What is the output of following code? Whether it is a general program or a recursive program. So how will you know whether it is a recursive program or not? Here, observe here, there is a function called f with a parameter called b. We are passing on a parameter b, and this is the base condition. If b equal to 0, return n. This is the base condition. This is the base condition. So here, what condition they given? Return. If this condition is true, it is a return LST. So if this condition is not finding, it comes down here. It is finding the digit b modulus 10. Then LST will append dig, and f equal to b by 10. That means at the end you are writing this statement. At the end you are writing this statement. So that means after when the function is returning, it performs nothing later on. So that means this also comes under your tail recursion. Now f is calling f. So it is my recursive program. It is my recursive program. But they are asking what is the output of the code? What type of output you will get this? If you observe this code, now it is asking enter a number. First you are entering a number. For example, my number is 123. Assume. And you are passing that n as a parameter. That means you are calling function with f with n as a parameter. It goes there. It is function f. When the function goes here, we are passing n. So n value how much? 123. So it goes here. So f having 123. So that means the value of b is 123. Now here checking whether b equal to 0 or not. No, b is not 0. If b equal to 0, you are returning the LST. Okay. Now it is doing what? Digit equal to b modulus 10. Every time it is taking the last digit. B modulus 10 means it gives you the last digit. So 123 modulus 10. 1 module answer is 3. That means the digit is 3. So LST dot append. Initially LST is what? It is empty. So there is a list with empty. That means it is empty list. It is a empty list. Now here you are appending LST dot append. So what is the digit? 3. So 3 is appended here. So 3 is added here. After that you are calling again same function with by 10 integer division. Because in Python when you say double slash, it is a integer division. So 123 by 10. So it is become 12. So second time you are passing 12. Now 12 equals 0. No. So this condition fail because the base is not satisfying. Now here 12 modulus 10. So when you say 12 modulus 10, answer is how much? 2. Now append. LST dot append. So 2 is appended here. So 2 is appended to list. Then again is calling f b by 10. Now what is the value of b? B is 12. 12 by 10. 12 by 10 means integer division. So 1. So when you say 12 by 10, so automatically 1 is passed. Now it is checking 1 equals 0. No, this condition is also not satisfying. 1 modulus 10. 1 modulus 10. How much? 1 modulus 10 is 1. Now LST dot append. So it is appending again. Every time it is finding the digit and appending. So 3, 2, 1. Now again b by 10. B and how much? 1. 1 by 10. 1 by 10 is how much? 0. So whenever 0 comes, this condition satisfies. 0 equals 0. Yes. So return the list. So that means when this condition satisfies, it returns the list. So that means the recursion is stopping here itself. So finally it returns the list. So when the list is returned, finally this list is returned because it's calling 3 times. 3 times this list is returned, and finally this function f is calling sum of LST. Sum of LST. When the function is returned, sum of LST. So the sum function is adding all the numbers. So 3 to 1. So this answer will be 6. That means what? It is adding the digits of a given number. So they will ask what is the output of the code. So the answer is 6. Because sometimes they may ask this way. So this way you can read. Or sometimes they may ask write a program to add all the digits of a given number. Then you should write the program in this way. So this is a recursive approach. Next one is recursive program. Another program they given. What is the output of the following code? They have written a function called g and passing one parameter, because while writing a recursive program, I told you there are two things. One is parameter, second one is the base condition. So parameter is passing how many parameter? Only one parameter, and the condition base condition is n equal 0 or n equal 1, return 1. If this condition is true, return 1. Otherwise, n into g minus 1, that means g is calling g. So whenever the function is calling itself, then it is a recursion. Now here, g is calling with g. With how much? It is calling n into g minus 1, n minus 1. That means the function is calling itself. Now here, num equals 7. So whenever num is 7, it is goes here, g become 7. That means n is 7. N equals 0, no. It comes to else part. So 7 into g of n minus 1. N is how much? 7. 7 minus 1 is 6. Again, second time it goes here. 6 is 0, no. So 6 into g of n minus 1. Because n is now 6. 6 minus 1 is 5. So it comes here. Now next time, 5 equals 0, no. It comes to else part. So 5 into g into 4. Because every time the value of n is decreasing. This comes to this else part. In else part, it is decreasing the value. Again 4 into g of 3. Again goes there. So 3 into g of 2. Again 2 into g of 1. So that means until 1 it goes there. Whenever n become 1, return 1. So that means this condition is satisfying. So whenever n equals 0, this value returns 1. So 2 into 1, how much? 2. So that 2 will be returned. So this value become 2. So 3 into 2, how much? 6. So 6 will be returned from this place. It goes here. So this becomes 6. So 4 into 6, how much? 24. So this function will be getting 24. So this 24 is multiplied with 5. So 24 into 5, 120. So 120 goes here. 120. So the G5 is getting 120. 125 into 6, how much? 720. 720 into 7. So 7 0 0 7 2 14 1 7 7 49 plus 1 5 0 4 0. So this will be the output. So this way it is okay. Okay. So the output will be 504. That means what? This program is nothing but your factorial program. Because sometimes they may not give the same name. So they will give different name, but they will ask what exactly this function does. Then you should say this function is calculating n factorial. N factorial. So if I pass n as a 7, then the answer will be 5040. So this way you can evaluate. Next they will ask what is linear search. Then you should say linear search is also one of the searching technique, which is searching the element from the list in a sequential manner from beginning to till the end. And remember, linear search is one of the simplest searching technique. Finds the element in the list by searching the element sequentially until the element found. Similarly, they will ask what is meant by binary search. Binary search also one type of searching technique in which it tries to find the element from the middle of the list. It is trying to search the element from the middle of the list recursively until the middle element is matched in the searching element. If sometimes data may be there, may not there. If data is not there, then you say data not found. And for linear search, the best time is order of 1. And for linear search, the worst time case is order of n. Of course, the average also order of n. This is the average case. Similarly, for binary search, the best case is order of 1. When the best case will come, whenever the element available in the first middle itself. That is, so in the worst case, order of log n. And in the average also order of log n. So this is the way you can answer. Because sometimes they will ask, what is the time complexity of linear sets in the best case? Then you should say order of n. Most of the time in exam, they will ask this question. What is the time complexity of linear sets in the worst case? So generally, the element if available at the end, or if the element is not found at the end it's also, then it is keep on searching from beginning to till end. So that is order of n. Similarly, in the binary search also, if the element is not found, then you may be keep on searching till end. Then in that case, the time complexity is order of log n. Sometimes they may ask a question, what is the minimum condition to be satisfied for binary search? Before implementing binary search, what is the minimum requirement? The minimum requirement is data must be in a sorted order. For linear search, no conditions. So whenever you want to implement binary search, then the best criteria for binary search is element must be in a sorted order. And for linear search, there is no sorting condition required. Or sometimes they may ask a question, in which type of searching condition or in which type of searching algorithm sorting criteria is essential. Then you should say for binary search. Sometimes they will ask, what are the different types of asymptotic notations are there? And what do you mean by asymptotic notation? Then you should say, asymptotic notations are the mathematical notations. It is used to represent the running time of algorithm. So how much time it takes, how much time requires to solve a problem, that time complexity can be represented through asymptotic notations. So for every program, it requires some time. So the time factor you can represent through asymptotic notation. There are three standard notations. One is big O notation, omega notation, and theta notation. These are the three asymptotic notations generally used to represent the complexity of algorithm. Remember, they will ask which notations are used to represent the complexity and what do you call, and that is that is known as asymptotic notation. And what are the standard asymptotic notation? Then you should say these three: big O, omega, and theta. And when you would use big O notation generally useful for representing the worst case. And when to use big omega, this should be used for to represent the best case. And when to use big theta, this is useful for average case. So for every algorithm, there are three cases: best case, worst case, as well as average case. So for different cases, different notations can be used. So these are the different types of asymptotic notations. So these notations you would use effectively. Similarly, what are the different asymptotic notations are there and different styles are there? And there are common asymptotic measures are there. Some algorithms may require constant time. So whenever a program requires constant time, then you can say it is order of 1. For example, I may ask, what is the time required to find 5 to the power 0? The answer is 1. If I ask 10 to the power 0, it is always 1 only. If I ask 15 to the power 0, always 1 only. That means for every number or n to the power 0 is always 1 only. Fixed. That means the program requires always constant time. So I can say it is order of 1. Order of 1. Or if I ask how much time required to multiply 5 into 8, this is fixed time because A is 5, B is 8. A into B, that is fixed. So whenever it is fixed, that means constant, then the processing time is always fixed. Then that is order of 1. So remember, whenever the program requires same amount of time for every input, then you can say it is order of 1. Whenever the value changes based upon the input, then you can decide which one is the next one. Sometimes the program may takes in a binary division format. Then those things requires logarithmic time. Whenever the divide and conquer policy comes, whenever the program is implementing divide and conquer policy, then the time complexity can be represented through in a logarithmic pattern. So the asymptotic notation can be represented in a the time complexity of that program can be represented using this order of log n time. So for divide and conquer policy based algorithm requires order of log n. Similarly, if the program takes linear time, then that means order of n. Order of n. For example, I may say for I equal 0, I less than n, I plus plus, print I. Print I. So how much time it takes? If n is 5, it repeats 5 times. If n is 10, it repeats 10 times. If n is 100, it repeats 100 times. That means it takes linear time. So based upon the value of n, the time factor is changing. So in that case, it comes under the linear category. So the time complexity is order of n. Sometimes it may be combination of linear with logarithmic, linear with divide and conquer. So in that case, order of n log n, because sometimes the program may have both linear combination with logarithmic pattern. So it is order of n log n. Sometimes it may go for quadratic. That means loop within a loop. So whenever a loop within a loop comes, which is repeating same number of times, n into n time. That means, for example, I'll say for I equal to 0, I less than n, and I plus plus. This is my outer loop. And one more I'll write here, j equal to 0, j less than n, and j plus plus. And some statement. In that case, how much time it takes? Because my outer loop repeats n time. Inner loop also repeats n time. So n into n, n square time. So this comes under your quadratic. So this is order of n square. So the time complexity can be represented by order of n square. Fine. Similarly, cubic. For example, you write for within a for within a for, 3 for loop. That means n into n into n. That means n cube. So that is order of n cube. So while writing algorithm, you may be very careful how much time it takes to solve this problem, and whether it is a constant or logarithmic or linear with a logarithmic or quadratic or cubic. Sometimes even it is exponential also. If it is exponential, it is 2 to the power n. That means 2 into 2 into 2 into 2 into 2 n times. So 2 into 2 into 2 n number of times. That means 2 to the power n times. So in that case, it is exponential case. So while writing algorithm, the algorithm may come under any of the cases. So you must be very careful if it goes for exponential. Exponential takes a lot of time to solve the problem. Okay. If at all you are able to solve with constant time, then the algorithm is the best one. For any input, if it takes constant time, that is the best algorithm. So these are the standard notations are there to represent the time complexity of algorithm. And they may ask a question, which one is the best one? Then you should say order of 1 is the best. And which takes more time than order of 2 per n, that is exponential. So this is the way you can evaluate. Similarly, they will ask, what do you mean by sorting? Sorting means what? Arranging the data in a order, either ascending or descending. There are different types of sorting also there. One is called in-place sorting, second is called external sorting, and one other is called stable sorting. There are various kinds. First, they will ask, what do you mean by in-place sorting? Then you should say, it sorts the list only by modifying the order of the element within the list. Insertion sort and selection sort, in-place sorting, that means in the same place itself. It will not consume any extra memory. Whatever the memory is given, in that memory area you are able to sort it. So insertion sort and selection sort are in place sorting, as they do not use any more additional place. Where is your bubble sort, which takes temporary variable for sorting? Similarly, what do you mean by external sort? External sorting means which is bringing the data from outside and means the external memory area for sorting. For example, your merge sort. Merge sort comes under your external sorting. When all the data that needs to be sorted cannot be placed in memory, whatever the memory is available with you, it's not sufficient, then that sorting is called external sorting. Okay? When all the data that needs to be sorted, which cannot be placed in memory at a time, then the sorting is called external sorting. External sortings are useful for massive amount of data. Whenever you are having a huge amount of data, that time the external sortings are useful. There are variations of typically useful for external sorting. Some external sortings like means the external storage like hard disk, CD, etc. are useful for this. So whenever you are having a huge collection of data, that time you need some more additional memory. That additional memory may not be available in the RAM itself. You may need some external hard disk or CD. So that time you can use this external sorting. Similarly, there is something called stable sorting. Stable sorting means what? A sorting algorithm is said to be stable if two objects in the equal keys appear in the same order of the sorted output. Then that type of sorting is called stable sorting. That means the way you are giving the input, in the same way the output should come if the two keys are same. That means, for example, here, observe here 10, 20, 20, 30, 10. Now here 10 is available two times. Please observe here 10 in a green color, 10 in the brown color. And there is a 20 also two times. 20 in the brown color, 20 in the... So my input is given in this format. So after sorting, I should get in the order, no doubt. But whichever 10 comes first, that's same. Now see, green color 10 come first. So after sorting also, I should get the green color 10 first. But the brown color 10, that should come next. I should not get, even the values are same, but the green color 10 came first and this brown color 10 came last. So it should maintain the order of the same key. So this 10 comes first and then this 10. If at all you are giving first to brown color 10 and then next to green color 10, then it is not a stable sorting. It is unstable. So it is not a stable. But if you are getting green first and then brown, then it is stable. Similarly 20. If you observe 20 here, brown color 20 came first. While giving the input, brown color came first, then green. So while sorting also, you should have the same order. You should not change. Similarly 30. 30 came first. So this is a stable sorting. Stable sorting. So sorting is stable because the order of the ball is maintaining the value of the same. The ball with the green color and the value 10 appears before the orange color. So ball with 10, similarly the order is maintained. Which sorting algorithms are stable? One is bubble sort, insertion sort, and merge sort comes under stable sort because it will be maintaining the order of the key. Whichever order comes the data, same order, the output will come. The stable sort always checks for the input order. So in the output also same order, the data should come for the same way, not for the different way. Similarly, which are unstable, your quick sort and heap sort are unstable. It will not arrange the same order. Okay, thank you. So the remaining one we'll see in the next session.
Like, share and subscribe. Hit the bell icon for more updates.